So good morning, everyone, and welcome to today's lecture. This is lecture number 3 in current, and we will be winding down current in this particular session. In the previous class, we had discussed some of the electrical instruments. We had seen emitter. Emitter is a device which is used to measure current. It is normally connected in series. Not normally, it has to be connected in series. For an ideal emitter, the resistance has to be 0. Voltmeter is connected in parallel. It is supposed to measure the potential difference between 2 points in a circuit. It is connected in parallel. For an ideal voltmeter, the resistance has to be infinite. Galvanometer is a very sensitive device which works on the principle that a current carrying coil, if placed in a magnetic field, it will experience a torque, and that torque or that deflection will be directly proportional to the current. BINA is equal to C phi. Then there are two terms that you must understand. One is current sensitivity, other is voltage sensitivity, and the third one is full scale current. We had also seen what is shunt. Any resistance which is connected in parallel with the galvanometer is known as shunt. Now, what we are going to see is the conversion of galvanometer into the various device and galvanometer into emitter. Now, what do you mean by galvanometer into emitter? Now, emitter is a device that is used to measure current. Galvanometer is also a device which is used to measure current. Why I need to convert it? Now, remember, galvanometer is a very sensitive device. It can measure very small values of current. But again, the other problem is, since it can vary very small values of current, it cannot measure large values of current because it will go boom. If the amount of current that passes through the galvanometer is more than the full scale deflection current, the galvanometer will go boom. If I want to measure bigger currents, larger currents, that cannot be done using a galvanometer. Therefore, we have to increase the range of the galvanometer so that we can measure larger currents. Hence, the galvanometer gets converted into an emitter. So basically, an emitter, whenever it is measuring large values of current, it is basically a galvanometer whose range has been changed and which is now acting as a emitter. Now, how are you going to convert a galvanometer into an emitter? To convert a galvanometer into an emitter, we have to connect what?
Resistance in parallel to galvanometer.
We have to connect a resistance in parallel to the galvanometer, and this resistance is known as the shunt resistance. Do we understand this? This resistance is known as the shunt resistance. Now, how it is going to measure the current? This I is the range of the emitter. This is the maximum current that this emitter can measure. When the maximum current passes through the circuit, the current that can pass in the maximum state is Ig, which is the full scale deflection current of the galvanometer. And with this arrangement, we can convert a galvanometer with a very small range into an emitter of a given range I. Do we understand this?
Yes, sir.
This is how now this entire thing, which you can see here, now becomes an emitter. This entire thing now becomes an emitter, and this entire thing can be now written like this. This R is the equivalent resistance of this combination. And what you need to remember about this equivalent resistance of this combination, as you can see, it is very clear. This equivalent resistance of this combination will be equal to how much? This equivalent resistance of the combination will be equal to Gs upon G plus S, where G is the resistance of the galvanometer or resistance of the coil of the galvanometer. Do we understand this?
Yes, sir.
Now, normally, when you are given a question of conversion of galvanometer into an emitter or conversion of galvanometer into a voltmeter, the things which are known to you is the range of the emitter, is the full scale current of the galvanometer, and the third thing that is known to you is G, the value of resistance of the galvanometer. The unknown quantity is always the value of the shunt resistance. So, in normal case, what is given to you? I, the range of the galvanometer, Ig, and G are the known quantities, and S, the shunt, is the unknown quantity. So, you basically have to find out the value of the shunt resistance. Do we understand this?
Yes, sir.
Now, how do you find out the value of this shunt resistance? It is very simple. If you go in this pink path, or if you go through the green path, the potential difference between these 2 points will remain same. Yes or no?
Yes, sir.
Because both of these are parallel paths. I hope you don't see it. Whether you go in the pink path, the upper part, or you go in the green path, the lower part, the potential difference would be same. Do we understand this?
Yes, sir.
Since the potential difference is same, you can find out the value of the shunt resistance S. The value of the shunt resistance S will be given by this formula Ig into G divided by I minus Ig. Do we understand this?
Yes, sir.
So, henceforth, you will know the value of the shunt resistance as soon as you connect this shunt resistance in parallel with the galvanometer. The galvanometer instantly changes its range and it becomes emitter of the given range. Do we understand this?
Yes, sir.
Many a times it is given that you want to pass nth, one third, one fourth, one fifth part of the main current through the galvanometer. In that case, Ig becomes equal to I divided by N. Do we understand this?
Yes, sir.
In that case, if you can just put it in the formula, the value of the shunt resistance S becomes G upon N minus 1. Do we understand this?
Yes, sir.
Now I'll give you time to note this down. Here you can also note in most of the cases this I, the range of the emitter, is very large compared to the Ig, the current, that the full scale current of the galvanometer. In that case, you can write this S, the shunt resistance, can be written as approximately equal to Ig into G divided by I. So that becomes a very good approximate formula, and in almost all the cases you will end up with the right answer with this approximate formula also, because normally I is very large and the full scale deflection current of the galvanometer is normally very less, so you can use this formula as well. The next thing that we are going to see is the conversion of galvanometer into voltmeter. Now, by common sense or logic, you can tell me how are we going to change a galvanometer into a voltmeter?
By connecting a resistance in series with voltmeter.
Listen to the question carefully. How do I convert a galvanometer into a voltmeter of a given range?
We should connect resistance in series with galvanometer.
We connect a resistance, a high resistance in series with the galvanometer. This high resistance is R. This V is the range of the voltmeter. So this is the maximum voltage that this voltmeter can measure. When the voltmeter is measuring the maximum voltage, the current through the galvanometer is IG. Do we understand this? This entire thing now becomes your voltmeter. Do we understand?
Yes, sir.
And you can write this entire thing like this. You can write this entire thing like this. This is the R equivalent. And how much will be the R equivalent in this case?
R plus G.
The R equivalent in this case, it is very simple to see and understand. It would be the addition. It would be the simple addition of G, the galvanometer resistance, and R, the resistance which is to be connected in series. Now, again, the unknown quantity here would be the value of R. Do we understand this?
Yes, sir.
The value of R could now be found out. The total value of V will be equal to Ig into G plus R. Do we understand this?
Yes, sir.
So from here you can find out the required series resistance of the galvan or of uh, the required resistance which has to be connected in series to convert the galvanometer into a voltmeter. Do we understand this?
Yes, sir.
Then sometimes they ask if nth part of the voltage, what will be the value of the resistance if nth part of the voltage has to be applied across the galvanometer, or the external resistance. In that case, the resistance which has to be connected in series becomes n minus 1 into G. All of us understand this.
Yes, sir.
Everyone understands this.
Yes, sir.
Now, remember this G. This G is normally very, very small compared to this S. Normally, it is very small compared to this S. So, in this case, you can neglect and write an approximate answer. As in the first case, here the value of G is going to be very, very small compared to S. So you can write the formula of this R as V divided by Ig. This will give you a very good approximate result for this case. Do we understand what I have done here? Yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. Let me know once you are done. Then this is the first question that we are going to solve. What is the value of shunt which passes 10% of the main current through a galvanometer whose resistance is given as 99 ohms? The answer that I am having is 11. So how are you supposed to do this? The only formula that you know here is G into Ig will be equal to I minus Ig into S. Shunt resistance is G into Ig upon I minus Ig. You just need to put the values and get the answer from here. What is the answer that you are getting from here? My sheet says it is 11 ohms. Unless and until you prove me otherwise, I will take 11 ohm as the correct answer. Do we understand this? How it is done?
Yes, sir.
That takes us to the next question. Everyone has noted this down? Oh, I forgot to tell you in this question, the value of IG is the value of IG is I by 10.
Yes, sir.
If the value of I is I, the value of IG is I by 10. Do we understand this?
Yes, sir.
Shall we move on to the next question?
Yes, sir.
As I keep on telling you, your calculations are out of the world. You must work on your calculations. Calculations are not up to mark. A fifth standard, a fourth standard student has better calculating skills than you guys. So you need to improve on that. You're better than a fourth grader. My son he's in second standard. He does not know how to divide. I think he is better. If I tell him how to divide, he will be better than you guys. Okay, this is the next one. 20% is the correct answer. It should not have taken so much of time for you to give me this answer. In first case, the current is 5. In second case, the current is 4. 5 minus 4 is 1. 1 divided by 5 into 100 is 20. I have done this in 5 seconds. And you need copy, pen, rubber, scale, everything. These are the type of questions that are coming in the exams. And if to solve this question, you need copy, pen, rubber, scale, compass, and instrument box. You're not doing good. These are all mental question. I just have to look and I just have to give the answer, nothing else. The only thing that matters in JEE right now is speed. If you need the speed of Vande Bharat train, right now you are moving in a bullock cart. And you need the speed of a Vande Bharat train that moves at around 180, 200 kilometers per hour. This is the next one. Find the reading of the emitter. Is this the current through the 6 ohm? So basically he's asking what is the current through the emitter branch and what is the whatever current through the 6 ohm branch. Let's see who can give me the answer. And also we'll see in which train are you traveling. Vande Bharat, Shatabdi, Express, passenger, goods train, or my favorite, tractor, or the least, bullock cart, or maybe the leaster, walking.
The current
The reading of the emitter is 4 ampere, okay?
and the current passing through 6 ohms resistor is 2 amperes.
The current passing through the 6 ohm resistor is 2 ampere. So if I connect the emitters in parallel, it will not measure the correct current. 6 into 6 and 3 in parallel is 2. 2 plus 1, 3. So the total current becomes I, which is 6 ohms, 6 amperes. It will divide in the ratio 1:2. So in the 3 ohm it will go 4 and in the 6 ohm it will go 2. So oral question that could have been done orally as I have already told you. Let's see. This one. Find the potential difference across the 300 ohm resistance in case A and B. In case A, it is the actual potential difference. In case B, it is the potential difference that the voltmeter would measure. Do we understand? So from there, you can find out the percentage error in the voltmeter. In first case, the potential difference is 60 volt. Okay.
In second case, the potential difference is 25 volt.
After 5 minutes, I get an answer, and an absolute rubbish answer I get. So as I told you, the only thing that you have to work on is your calculations. So from now onwards, you stop doing everything that you have done till now. No physics, nothing. Just calculate. Because the calculations are getting worse every day. Anyways, even at an age of 43 years old, I can do this question without touching my pen, keeping my hands here like this. One resistance is 200 ohms and the other resistance is 300 ohms, and they are connected in series, so they will divide in direct ratio of their resistance. So the voltage across 300 ohms will be 300 into 100 divided by 500. That will be 60. You can calculate, and this pen is here. So the potential difference across the 300 ohm will be 60 volt, direct ratio. And the potential difference across 200 ohm will be 40 ohms, 40 volts. Then in the second case, when the voltmeter is connected, the effective resistance between the 300 ohm resistors, 300 and 600 are in parallel, it becomes 200, 200 and 200 are in series, both the resistances are same, so the voltage will be divided equally. So in the second case, the answer is 50 volt. The first case answer is 60 volt. What is the percentage change? 60 minus 50, 10. 10 divided by 60 into 100. 1 goes. 100 by 6% is the percentage error. That is the answer, my dear friends. I don't know what you are doing. And I never touch my pen. So if we need the speed of Vande Bharat, we are moving on 11 number ki bus. Tick, 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 tick. So to go from your coaching to the nearest IIT, which is IIT Hyderabad, you will take a long time because you are walking on foot. Have you understood what I have told you? How did I calculate? Yes or no? See, I can't teach you calculations. I've already told you to practice. How many of you practiced it? How many of you? Why I need to practice? I am in very 12 standard. I have clear 12 standard. Why do I need to practice calculation? Huh? I am good with calculations. Na 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 na. Anyways, I pray to God and all the goddesses, Saraswati Mata and all those Matas and Pitas. Please help these students, please, because they are at your mercy now. So every day when you get up, the first thing that you are going to do is pray. The second thing you are going to do is pray. Third thing that you are going to do is pray. Pray, pray, pray. Because only prayers are going to save you now. A voltmeter has a resistance of 6 ohms and a range of V volt. Calculate the resistance to be used in series with it to extend its range to N times V. No. No, 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 no. Na, 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 na. Let's see. Now this. So how I'm supposed to do this? The present range is V volt and the resistance of the galvanometer is G ohms. Now when this is reading its maximum potential difference, the current that will be flowing through it will be Ig. Yes or no? Do we understand this?
Yes, sir.
Now I want to change the resistance to V1, and this new resistance V1, if you remember, it will be equal to R plus G into Ig. Yes or no?
Yes, sir.
Now this new voltage, new range is n times the original one. So n times V is R plus G into Ig. Ig is V by G. So from here you will be able to calculate the value of the series resistance, and the value of series resistance that is going to come will be G into n minus 1. These are the type of questions that are coming these days. Simple questions. It just requires you to concentrate. Close your eyes. Concentrate. You just have to do simple multiplication and divisions. Nothing else. Simple concepts, simple things. Concentrate on those simple things. Do simple things correctly. So this is the answer for this one. I hope we have understood this. Yes or no?
Yes, sir.
That takes us to this fundamental question. I've seen a question of this nature come in some JEEs, not the recent ones, but 5 or 6 years back. Have you noted this down?
Yes, sir.
This is the next one in line. Tells us everything about the galvanometer that they can ask. A galvanometer with a scale divided into 100 equal divisions has a current sensitivity of 10 divisions per milliamp. So for 1 milliamp, it will go 10 divisions. And the voltage sensitivity of 2 divisions per millivolt. What adoptions are required to use it? Number one, to read 5 ampere full scale and 1 division per volt. So this question encompasses everything that we have done about emitter, voltmeter and galvanometer in one. Think about it. Be the answer. So how are we supposed to solve this? You have to convert this into an emitter whose full scale reading should be 5 amps. You have to get the value of the shunt resistance. But to get the value of shunt resistance, you have to find out the value of the galvanometer resistance. How are you going to find out the value of galvanometer resistance? Ig, full scale deflection current of the galvanometer. Do you know how much is the full scale deflection current of the galvanometer?
5 milliamperes. Sorry, 10 milliamperes.
So it's very simple. It is 10 divisions per milliampere, 100 divisions. So the full scale deflection current becomes 10 milliampere. What is the full scale deflection voltage?
50 millivolts.
50 millivolt. From there, you can find out the galvanometer resistance. How much will the galvanometer resistance come?
5, sir.
5 ohm. That is the answer, my dear friends. After that, everything is simple. To find out the value of the shunt resistance, you can simply put the formula G into Ig divided by I minus Ig. Instead of I minus Ig, you can simply use I because Ig is very, very small. So your Ig is 5 into Ig is 10 milliamps divided by your current is 5. So your answer becomes 0.01 ohms. That is your value of the shunt resistance. Do we understand this? To find out the value of the series resistance, you can use this formula. V is equal to Ig into R plus G. 1 division per volt. That means the range will be 100 volts. So 100 divided by Ig. Ig is 10 milliamps. That will be equal to R plus G. G is 5. From here, you will get the value of R as 9995 ohm. And these are the answers that I was looking forward to. I'll give you a minute to note this down. The next heading is Wheatstone Bridge. We have already seen what a Wheatstone Bridge is. We'll just write it once officially. A balanced Wheatstone bridge happens when P by Q is equal to R by S. We have already seen that if the ratio of P by Q is less than R by S, then the current will flow from point B to point D. Just note it down so that if a question comes, you already know the answers to this. I know that it's very difficult for you to remember, but I can't help it. Again, the only thing I can do is pray to God that you will remember it. Balanced Wheatstone bridge. If P by Q is equal to R by S is balanced, no current flows. If P by Q is less than R by S, current flows from B to D. If P by Q is greater than R by S, current flows from D to B. And the next thing that we are going to see is a meter bridge. And as the name suggests, it consists of a wire of length 1 meter. So as you can see, you have a battery connected to this wire and two resistance. One is a known resistance which is kept in this resistance box, and one is an unknown resistance S. Now when you put the key on, when you start the circuit and you move the jockey, at some point you will have zero deflection in the galvanometer. When the galvanometer showing zero deflection, that means the Wheatstone bridge is balanced. Yes or no?
Yes, sir.
So resistance of this resistor, let us call this as R. R divided by resistance of this point P, this wire, will be equal to S divided by the resistance of this part. And you know that resistance of a wire is equal to rho L by A. If everything is same, the resistance of the wire, if the temperature is same, the resistance of the wire is directly proportional to the length L of the wire. Yes or no?
Yes, sir.
So P by Q, if I call this as Q, P by Q will be equal to R by S. From there you can calculate the value of S if the known resistance R is known to you. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then this is the next question, a simple one. In a meter base, the balancing length from the left end and the standard resistance of 1 ohm is in the right gap. It's not gas, it is gap. Is found to be 20 centimeters. Remember, the length is measured from the left. The value of the unknown resistance is how much? And so the answer is 0.25 ohm. The diagram is like this. This distance is given as, this balancing length is given as 20. The other one will be 80. The unknown one is put here and the known one is put here. So you can have x divided by 20. You can write it like this. X divided by 20 will be equal to 1 divided by 80, and you end up with your answers. Do we understand this?
Yes, sir.
Chalo then, fatafat, solve these 2 or 3 questions so that I can move ahead, assuming that you have understood this. A scale of a galvanometer of resistance 100 ohms contains 25 divisions. It gives a deflection of 1 division on passing a current of 4 into 10 raised to the power minus 4 ampere. The resistance in ohm added to it so that it may become a voltmeter of range 2.5 volt. The answer is 150 ohms. So first of all, you have to find out the full scale deflection current. How much is the full scale deflection current? So the full current for one division is this, multiplied by 25 divisions. So this becomes your full scale deflection current, 10 raised to the power minus 2 amps. Yes or no?
Yes, sir.
You have to convert it into a voltmeter. So you can just put the formula of resistance in series. The formula is V divided by IG minus G. You put the values, get the answer, and you stay happy. Do we understand this?
Yes, sir.
So I hope you can do questions of this nature. Let me move on to the next category, next type. Already done some questions on this. These are the questions that are in fashion. The following figures, emitter and voltmeter, reach 2 amps and 120 volts respectively. What is the resistance of the voltmeter? So how are we supposed to do this? Between points X and Y, the potential drop is 120 volt. Do we understand this?
Yes, sir.
That's it. So this 120 volt shall be equal to total current I. And how much is the current I? It's 2 amperes. 2 multiplied by the equivalent resistance between the 2 points. So from here you can get the equivalent resistance as 60. This equivalent resistance 60 will be equal to the parallel combination of voltmeter with this. So this will be R, the voltmeter resistance, multiplied by 75 divided by R plus 75. This will give you the answer for the value of R. The answer that I have is 300 ohms, and that I would suspect is the correct answer for this question. The resistance of the voltmeter R, the resistance of the voltmeter R, the resistance of the voltmeter R is 300 ohms. Do we understand this? You were doing the same thing or you were doing something else?
This one only, sir.
If you have applied the same formula, the physics part is okay. The only part that you must be worried about, and seriously you should worry about it a lot, is your calculations, because your calculations are not going anywhere. Anyways, in the circuit shown in the figure, what is the reading of the voltmeter? Remember, both this emitter and voltmeter would be taken as ideal. I hope you understand the meaning of ideal. So, assuming that both these emitters and this voltmeter is ideal. You can tell me both the answer. What is the reading of the emitter? What is the reading of the emitter? Second question, what is the reading of the voltmeter? Both of them are ideal. Voltmeter reading is 0 and emitter reading is 1 ampere. How did you get it? It is as simple as this. Emitter will read the current in this branch. How will the current flow? Current will go from here. Dig 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 dig. Current cannot go in that branch because it has infinite resistance. So current in the branch is simply 3 divided by 3, 1. Then you have to find out the potential difference across these 2 points. There is current flowing, but there is no resistance. So the word potential difference is 0, and therefore the answer for potential difference is 0, and for the current, the answer is 1 ohm. See, you can easily just keep your patience. The questions that are going to come are pretty straightforward and pretty simple. This is the next one in line. Voltmeters V1 and V2 are connected in series across a DC line. V1 reads 80 volts and has a per volt resistance of 200 ohms. V2 has a total resistance of 52 kilo ohms. What is the line voltage? Line voltage. Line voltage. Total voltage. Line voltage. Total voltage. Line voltage. The time starts now. And 240 volts is, my dear friend, the correct answer. And we have done such questions many times in many ways. This is how you can write it. This is the line voltage that you have to find out V. Let us call the resistance of this one as R1 and let us call the resistance of this one as R2. How does voltage divide in direct ratios? Yes or no? So I can say V1 will be equal to R1 upon R1 plus R2 multiplied by V. Yes or no?
Yes, sir.
Everything is given. V1 is given as 80 volt. R1 is not given directly, but it's given indirectly. Per volt, the resistance is 200. So you can find out the total resistance 200 multiplied by 80. Yes or no?
Yes, sir.
R2 is already given as 32 kilo ohms. The only unknown that is left is the value of V, which could be easily calculated from all this. And the answer that you are going to end up is 240 volts, and that is the answer that we were looking at. Do we understand this?
Yes, sir.
Comes this question. An emitter A reads 2 ampere and the voltmeter V reads 20 volts. What is the value of R? Same question, similar question we have done previously. So the current in this branch is 2 amps and the potential difference across these 2 points is 20 volt. That means the effective resistance between points A and B, the effective resistance will be how much? It will be 10 ohms. The effective resistance will be 10 ohms. And these consist of 2 resistance in parallel. The combination of 2 resistance in parallel is 10 ohms. That means it has to be more than 10 ohms. Then only you can get, whenever 2 resistance are connected in parallel, the effective resistance is always less than the smallest value. Do we understand this?
Yes, sir.
Okay. So this is the answer for this one. That takes us to the next heading, the next device, and the next device is known as potentiometer. 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 And the primary circuit of a potentiometer is simply like this. It consists of a wire of uniform cross section and a steady current is flowing in the wire. A steady current is flowing in the wire. So, as you can see, this is a potentiometer wire with, and we allow a steady current to flow in this wire. The steady current maintains a uniform potential gradient along the length of the wire. What do you mean by potential gradient? Did I tell you the meaning of potential gradient? Yes or no?
Yes, sir.
Potential gradient. If you have 2 points, A and B, the potential difference is delta V. The distance between the points is delta L. Potential gradient is delta V by delta X, or it is dV by dx, that is known as the potential gradient. Potential gradient is constant. Therefore, if the potential difference is constant, any potential difference which is less than the potential difference, so any potential difference which is less than the potential difference between A and B can be measured using this potentiometer wire. Do we understand this? Any potential difference which is less than this potential difference across the wire can be measured using this. Do we understand this?
Ye-
Do we understand this?
Yes, sir.
So any potential difference can be measured using this potentiometer wire. What else you can write here? Let me see. Okay, now if I talk about this potentiometer wire and if I write the equation, this circuit of this wire is known as the primary circuit. Oops. This is first write, first listen, then I'll give you time to write. This circuit is known as the primary circuit of this potentiometer. This is known as the primary circuit. Now, in this primary circuit, there would be a current that is flowing like this, yes or no? You can find out the value of the current. That current will be equal to E upon R plus capital R, where R is the resistance of the battery and capital R is the resistance of this wire. And we are assuming here that there is no other resistance. Do we understand this? So from there, you can find out the potential difference between the points A and B. Yes or no? VA minus VB, the potential difference between the 2 points will be E upon R plus R into R by L. Into capital R. Do we understand this?
Yes, sir.
We understand this?
Yes, sir.
Now, if there is any potential difference which is less than this value VA minus VB, that potential difference can be measured using this wire. Now, if I have to find out the potential gradient will be VA minus VB divided by L. Do we understand this? VA minus VB divided by L will be the potential gradient. Are we able to follow this, or this is going above our head saying bye bye?
Yes, sir.
So the potential gradient is given by this formula. Do we understand this, everyone, about the primary circuit? And this potential gradient is always kept constant for this wire. Do we understand this? So this has gone above our heads. Saying bye bye.
We got it, sir.
Bye bye. This is the primary circuit of a potentiometer. I'll give you 2 minutes to note this down. Then this is a small question that you can solve based on what we have seen. This is the primary circuit of a potentiometer. We have to find out what is the current in the primary circuit, what is the potential drop across the wire AB, what is the potential gradient, and what is the maximum potential difference that we can measure using this potentiometer wire. Yes, do we have answers here?
Yes, sir.
Number 1, current in the circuit. How much is the current in the circuit?
2 by 31, sir.
2 by 31. You have to just find out the total resistance. 1 plus 20 plus 10, 2 by 31. What is the potential difference across the points A and B?
20 by 31, sir.
20 by 31 volts. What is the maximum potential difference that can be measured with this potentiometer wire?
Sir, sorry, it is 21 by 31. Sir, 20 by 30. Okay. Nothing, sir.
What is the maximum potential difference that can be measured with this potentiometer wire?
20 by 31, sir.
What is the potential gradient dV by dL?
2 by 31, sir.
Volt per meter. Do we understand this, or this has gone above our heads? Saying bye bye.
Understood, sir.
Bakka?
Yes, sir.
Now, how do we measure an unknown voltage? How do we measure an unknown voltage using this potentiometer wire? So whatever we have seen, what are we going to do is we are going to put this unknown voltage in the secondary circuit, and we'll see this secondary circuit. This is just a brief of what we are going to do. So this A and B wire we have already seen. We will connect an unknown voltage. We will connect an unknown voltage with a jockey. Do you see this jockey?
Yes, sir.
And then we will move this jockey to a point where this jockey shows zero deflection, and when this jockey shows this zero deflection, this potential difference V will be equal to the potential gradient dV by dL multiplied by the balancing length L. Do we understand this? Yes or no?
Yes, sir.
Do we understand this? Yes or no?
Yes, sir. We understood, sir.
Do we understand this? Yes or no? अच्छे से everyone understands this?
Yes, sir.
So this is how this potentiometer can help us in measuring the unknown voltage. This X is nothing but the potential gradient. Do we understand?
Yes, sir.
I'll give you 2 minutes to note this down. So now this is the full circuit. We have a primary circuit and we have a secondary circuit. In the primary circuit, we have a key. When you put the key on, everything happens. There is a variable resistor so that you can change the current in the circuit. This is the jockey. Do you see this jockey? Huh?
Yes, sir.
This is the jockey. Then we have the resistance of the wire. Rho is the resistivity, specific resistance, and RH is the variable resistance. Do we understand the meaning of the terms? Yes or no? No, yes.
Yes, sir.
Pakka, everyone understands this?
Yes, sir.
Now, there are some points that you must remember about this wire, because these points may come as your assertion reasoning. They may come as knowledge based question. The specific resistance of this wire must be high, but its temperature coefficient of resistance must be low. Specific resistance must be high, temperature coefficient of resistance must be low. Otherwise, when the temperature increases, then the resistance of the wire would change, and we definitely do not want this. Yes or no?
Yes, sir.
So, we want the specific resistance to be high and the temperature coefficient is low. Normally, we use alloys of manganese, constant, and Eureka for this potentiometer wire, because they have very low specific resistance. Do we understand this?
Yes, sir.
So now I think the space is over, so I will have to give you time to note it down, the full circuit, and then some important points that are we going to write. First point is about the material of the wire. Then we can move on to the next point, which is the potential gradient. Potential gradient across the wire, V by L, where V is the potential drop across the wire. That will be equal to E upon R plus RH plus R. R is the resistance of the wire, RH is the resistance in the rheostat, and small r is the resistance of the battery. So we are giving you the precise information. Do we understand this?
Yes, sir.
So you can see that this potential gradient is proportional to all these things. What are the things on which this potential gradient depends on? The potential gradient depends on the resistance per unit length of the wire. It depends on the area of cross section of the wire. It depends on rho of the wire. It depends on the current flowing through the potentiometer. Do we understand this? Yes or no?
Yes, sir.
At the same time, it directly depends on all these factors. At the same time, it indirectly depends on the EMF of battery in the primary circuit and the resistance of rheostat in the primary circuit. Do we understand this?
Yes, sir.
All these points are coming as question in the exam these days. These are the questions that are in fashion. I'll give you 2 minutes to note this now. Now we can see the applications of potentiometer, where we can use this potentiometer. The first use for this potentiometer is that we can use it to compare the EMF of two batteries or two cells. So we have primary circuit, we have secondary circuit. In secondary circuit, you have two batteries, E1 and E2. Now, first of all, what will we do? You will put the switch to position number 1. Do you see this position number 1?
Yes, sir.
You will put the switch to position number 1, and you will look for the null point. Whenever you get null point, the potential difference, in that case, there will not be any current flowing through the galvanometer, so the potential difference will be equal to E1. Do we understand this?
Yes, sir.
So E1 in first case will be equal to X potential gradient into L1, yes or no?
Yes, sir.
Then you will put the switch to position number 3. In position number 3, you will again find out the null point. E2 will be equal to X into L2. So E1 by E2 will be equal to L1 by L2. Do we understand it? So this has gone above our head. Saying bye-bye.
Understood.
Everyone understands this?
Yes, sir.
I'll give you 2 minutes to note this down. So this is a question that you can solve in an experiment to calculate, to determine the EMF of an unknown cell. Its EMF is compared with a standard cell of known EMF 1.12. The balance point is obtained at 56 centimeter with standard cell and at 80 centimeter with the unknown cell. What is the EMF of the unknown cell? I hope you have understood the question. Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to give me the answer. So basically you just have to put the formula E2 by E1 will be equal to balancing length L2 by L1. So your E2 will be E1, which is 1.12 multiplied by 56 divided by 80. Or ulta, multiplied by 80 divided by 56. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
So the question can be given straightforward or a question can be given in this fashion. Now that is the first use of the potentiometer. There are many uses. The second use is this, to find the internal resistance of a battery. To find the internal resistance of a battery. Now to find the internal resistance of a battery, what we are going to do? We are going to have the circuit. In the first arrangement, the circuit will only have the battery. In the second arrangement, the circuit would have battery with a known resistor. So we want two arrangements like this. If I combine these two arrangements in one, the arrangement might look like this. So this is both the arrangements in one, and this arrangement might look like this. Do we understand this?
Yes, sir.
Okay. So in first case, what we are going to do, the switch K dash will remain open. When the switch K dash is open, only battery will come in circuit. That will be case number 1. Do we understand this?
Yes, sir.
When your switch K dash is closed, when your switch K dash is closed, the outside resistance will also come into the picture. Yes or no?
Yes, sir.
So then the circuit will become in case number 2. Do we understand this?
Yes, sir.
So in first case, only the battery is in circuit. In the second case, the battery and the known resistance are in the circuit. Do we understand this?
Yes, sir.
So in the first case, you are going to calculate the balancing length. Let me call that balancing length as L1. That balancing length will be equal to the EMF of the battery, yes or no? The battery may have some internal resistance. The internal resistance is not drawn. I'll just draw it. In first case, the null point which comes will be equal to the potential difference across the battery because only the battery is in circuit. Yes or no?
Yes, sir.
In second case, with the external resistance also coming, the potential difference, the null point will come, which will be equal to the potential difference across the battery because there will be current in the inside circuit. The current will flow in the inside circle. Yes or no?
Yes, sir.
The current will flow in the inside circle. So the potential difference that you are going to measure will give you the potential difference across the battery when the battery is discharging, yes or no?
Yes, sir.
We already know the formula for calculating the internal resistance, E by V minus 1 into R, yes or no?
Yes, sir.
From here you can find out that this R will be equal to L1 minus L2 divided by L2 multiplied by the R which is connected. Do we understand this?
Yes, sir.
So from this concept, you remember I told you that this formula is a very important formula. Do you remember this?
Yes, sir.
That is how the resistance is found out. We understand this, everyone?
Yes, sir.
I'll give you 2 minutes to note this down. And this is the question that you can solve to understand what type of question comes. The internal resistance of a cell is determined by using a potentiometer. In an experiment, an external resistance of 60 ohms is used across the given cell. When the key is closed, the balance length on the potentiometer decreases from 72. Remember, in the first case, it will be more. 72 to 60. Find the internal resistance of the battery.
Sir, 10 ohms.
10 ohms. Well done. R is equal to, L1 minus L2 divided by L2 into R. When I put the values, I'll get the answer as 12 ohms, not 10 ohms. I don't know what you have calculated, but if you calculate in your right senses, you will get this answer. And I will not elaborate any further. Did you get the answer 12 or still 10?
Got it, sir.
Thank God. God is great. That we can, just now we have seen the formula, just now we have put the values, and we are able to subtract and divide and multiply all three things at the same time. We are able to do. Oh no. First subtract, then divide and multiply. Three things. Oh God. You can do three things together. Well done. That takes us to the next question. A battery with negligible internal resistance is connected with a 10-meter long wire. Standard cell gets balanced on 600 centimeter length of this wire. On increasing the length of the potentiometer wire by 2 meter, what will be the null point displaced by? What will the null point be displaced by? Okay, to solve any question, if it comes in this fashion, you just remember, might not be able to do this. The ratio of null points L1 by L2 will be directly proportional to the length L1 and L2 because the resistance changes in the same ratio. So from there, you can find out the new length and the new null points. Do we understand this?
Yes.
Just note this down. Just note this down so that if any question comes, you can solve this. This was not I told you, so that's why I'm solving it. Find out the answer. The answer in this case would be 120 centimeters, I guess.
Yes.
And note down this question. Do not discuss this, and that is why I'm giving you the concept. Note it down, and meanwhile, I will move on to the next one. Noted it down?
Yes, sir.
Then this is the next question. A Daniel cell, spelling is wrong, is balanced on 125 centimeter length of a potentiometer wire. When the when the cell is short circuited with a 2 ohm resistance and the balancing length is shifted to 100 centimeter. Remember the first case, the balancing length is more. What is the internal resistance of the cell? Option B, 0.5 ohms is correct. You just have to put the formula R equal to L1 minus L2 divided by L2 multiplied by R. When you put the values correctly, I think you will end up with the answer 0.5 ohms. Do we understand this?
Yes, sir.
Having said that, let us now move ahead and see some questions on heating effect of current regarding this heat and all that. And these are the questions that are coming in the exam these days. So let us understand this heating effect of current. We have already seen that heating effect. We have already seen that in a resistor, whenever current flows in a resistor, energy is lost in the form of heat. Yes or no?
Yes, sir.
The power which is lost in the form of heat can be found out using I square R or VI, or it can be found out using V square by R. Yes or no?
Yes, sir.
Similarly, the heat loss delta H or delta Q will be I square RT or VIT or V square by R into T. Do we understand this?
Yes, sir.
We have also seen that maximum power transfer theorem also we have seen. Yes or no?
Yes, sir.
Now, whenever questions of this type come, they might come. Whenever questions of this type come, they might come basically on this what? Basically, these questions on resistance. Basically, these questions will come on questions on the bulbs and power of the bulb and so on. So you must remember, I've already told you about the power of the bulb. Yes or no?
Yes, sir.
I think we had done some question on the power of the bulb. I think we have not done question, so I'll give you question on this power of the bulb so that I think that these questions can come. So we will solve these questions on power or bulbs. There are a few categories of questions which I have seen, which have come over the years, and we will concentrate ourselves on those questions which are coming on the power of the bulb. Let us start with this question. We know this formula, yes or no?
Yes, sir.
I think we had solved one question on bulb. There's one more. These are the type of questions that are coming in the exam these days. If a bulb rating is 100 watts. So 100 watt is the power. 220 volt determine the resistance of the filament. That is the most important thing that you have to find out first. The current to the filament. If this bulb is operated at 110 volt supply, what is the power which is consumed by the bulb? Give you 2 minutes to give me the answer. So how are we supposed to get this? Power is V square by R. So you can find out the resistance as V square by P. Yes or no? So
Yes,
it
sir.
will be equal to 220 square divided by 100. Whatever is the answer, that is the answer. Do we understand this? And remember, this resistance remains constant for the bulb. Yes or no?
Yes, sir.
To find out the current to the bulb, you just divide power by the voltage of the bulb. Yes or no?
Yes, sir.
So power is 100 divided by 220. That will give you the resistance of the bulb. Yes or no?
Yes, sir.
To find out the power when the voltage has changed, it will be 110 square divided by R. Yes or no?
Yes, sir.
And you already know the R from here. Yes or no? I think the power will become 1 by 4th. Yes or no?
Yes, sir.
It will come as 25. Do we get this or this has gone above our head? Saying bye bye.
Understood, sir.
Pakka, sir?
Yes.
Okay. Now, in many cases, you can have questions like this. They ask you which bulb will glow bright, which bulb will glow slow, and so on. They connect the bulbs in series, and then they ask you which bulb will glow bright and which bulb will glow slow. Now, in series, the in series combination, the power consumed by the bulb, the voltages the voltages would be different, but the current would be same. Yes or no?
Yes, sir.
But the voltages would be different. So if I talk about the power consumed by the bulb, it is directly proportional to I square. Yes, sorry. Power consumed by the bulb will be equal to I square into R. Yes or no?
Yes, sir.
That means this power will be directly proportional to the resistance of the two bulbs. Yes or no?
Yes, sir.
Now this resistance of the bulb is inversely proportional to the rated power of the bulb. Yes or no?
Yes, sir.
Is V square by thing. So basically the bulb or lesser wattage will shine more. Do we understand this?
Yes, sir.
So if I connect the bulbs like this, the bulb of the lesser wattage will shine more. We understand this.
Yes, sir.
Okay. I'll give you 1 minute to note this down. Power ratings are different, voltage rating are same, remember. Then we can come to parallel combination. The bulbs have same voltage rating V and V, and they are connected across the same voltage V. Power ratings are P1 and P2. So the total power consumed in this case would be P1 plus P2 if the bulbs are identical. If the bulbs are identical, then the power will be N times P. Do we understand this?
Yes, sir.
Then here the voltages are same, and therefore the bulb of greater wattage will shine more. Do we understand this?
Yes, sir.
We will see this with one example, and probably you will be able to understand it more clearly. Okay, so I'll give you one example from somewhere. We'll see, and then we will be able to understand it in a easier way. Okay, so we can understand it with this example. In this example, I have two bulbs. The power rating is 10 watt and 20 watt, and they are connected across a battery of 24 watt. Which bulb will shine more? Once you understand this, you will be able to tell me what is the power consumed by both the bulbs. I'll give you a minute to solve it. The 10 watt bulb will grow more. Yes.
Total power consumed is 20 by 3, sir.
Okay. So how are you supposed to understand this? The current is going to be same in both. Yes or no?
Yes, sir.
Now the current is going to be same. The bulb which has more resistance will have more power. The bulb which has less resistance will have less power. If I call the resistance of this pink bulb The resistance of this pink bulb R1, that will be equal to V square 24 square by 10, and the resistance of this green bulb R2 as 24 square by 20. So R2 is more, R2 is less, R1 is more, and therefore power consumed by the first bulb will be more compared to the power consumed by the second bulb. Do you understand this?
Yes, sir.
And then I've already given you the formula, how much is the power consumed, the resistance. Power consumed by the first bulb, P1 would be equal to I square into R1, and power consumed by the second bulb, P2, will be equal to I square into R2. The total power will be P1 plus P2, but I've already given you the shortcut formula, P1 P2 over 1 P1 plus P2. You can just put that formula. I mean, to get the total power, you can just put the formula and get your answers. You don't have to go on to this. Yes or no? Do you understand this?
Yes, sir.
Well, with this, we come to an official end for this. I think I have told you everything that you needed to know about this particular chapter. We have covered everything, but there are a few things that I would tell you as important points. Um, you may use them in some questions if you feel like. There are some concepts. Even if you don't know them, it does not make any difference to your life. But since they are given in books, so I will just take them. The first concept is known as the grouping of cells. How are cells grouped, or combination of cells? Grouping of cells. Sometimes they might ask you a straight question in that, and I don't want you to be lagging in that aspect. So the first grouping of cell is known as the series grouping of cells. Now remember, in the series grouping of cells, you have a large number of cells connected to each other. Remember, they are connected with the same polarity together. If one of the cell is reversed, then you have to take them as minus. So this concept is only valid when every cell is in the same, this is connected in the same way. Do we understand this?
Yes, sir.
Then if they are connected like this, we can replace all of these cells by one equivalent cell. The EMF of that equivalent cell will be E equivalent, and this E equivalent will be equal to E1 plus E2 up till En. We have to write them. We have to write them with your polarity signs. Do we understand this? If one of the cells is connected in the reverse order, you have to change it. Do we understand this?
Yes, sir.
Similarly, the equivalent resistance of this cell will be equal to R1 plus R2 up till Rn. Do we understand this?
Yes, sir.
So this is the concept of equivalent cell in series. Now you can have these equivalent cell connected in a series combination like this. In a question, then you can easily find out the current will be given by this one. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
So you can straight away write the answer in this fashion. Sometimes they might give you the question in this fashion that some cells are connected in this polarity, some cells are connected in opposite polarity. If the question is given in that fashion, You can write the formula like this. If the polarity of M cell is reversed, then the equivalent EMF becomes N minus 2M times E, while the equivalent resistance remains same. Do you understand?
Yes, sir.
Give you 2 minutes to note it down. Here in the formula, it will be N minus M, not N minus 2M. So just change it. I took it in the other way, it is N minus 2M only. It's subtracted from the total, not the actual number. I thought it is the actual number. Correct. N minus 2M is correct. Then we have the parallel combination, and as you can expect, this parallel combination looks like this. No prizes for guessing this one. You have to use all this EMF with polarity, and the equivalent resistance will be the parallel combination. Do we understand this?
Yes, sir.
Okay. Just give me a minute. If you have a circuit like this, it is connected to an external battery. You can have this formula coming in, the I current will be equal to this much. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then you can have the next combination, which is a mixture of the two. M cells in series, and then you have N branches of the same. Do we understand this?
Yes, sir.
Here are the answers for it. And sir, then this officially brings us to an end for this chapter. It officially brings an end to this, a very big chapter. Now what is left in electromagnetism is not that big. Whatever is left in electromagnetism can be finished in a week. So that is the last week for electromagnetism that we are going to do. I'll give you time, 5 minutes, 10 minutes. Go back to whatever we have done in this chapter. First, go back to electric current, because now we are not going. Electric current will still be coming, because we have to do magnetic effects of current just after this. Electrostatics, capacitance, circuits are gone almost, unless and until a question comes in magnetic field of circuits, which is not there. Will not be going to come across electric circuits. Now we'll be only coming across AC circuits. We'll be solving AC circuit, but they are different from DC circuits. So give you time. Go through what we have done in electric current. Go through what we have done in capacitance, because capacitance circuits and electric current circuits are same. Go back, have a look. Capacitor circuits, electric current circuits, electric current, resistance, everything that we have gone through it. Go back, have a look. Ask me if you have any doubt whatsoever. Well, you can go and then solve this problem. This is a problem from last year's paper. In a given circuit of potentiometer, the potential difference E across AB is larger than E1 and E2 as well. For key 1 closed, the jockey is adjusted so that the touch the wire, there is no deflection in the galvanometer. Now the first battery E1 is replaced by second battery E2. The galvanometer shows null deflection as Z2. What is the ratio of A1 by B1? A by B. Give you 2 minutes. A is equal to 1, that is correct. So E1 by E2 will be equal to A by B. A is the length of the null point in the first case. We have to calculate from the same point. Let us calculate from the point A. From the point A, what is the value of the null point?
3.8 meters.
380 centimeters or 3.8 divided by the next position is where?
It's 7.6, sir.
So it is in the ratio 1:2. Do we understand this, or this has gone above our head? Saying bye bye.
Understood, sir.
Pakka, sir?
Yes, sir.
See, these type of questions are coming in the exam these days. Questions are pretty damn simple. See this question. As easy it gets. In an electrical circuit, a battery is connected to pass 20 coulombs of charge through it in a certain given time. The potential difference between the two plates of the battery is 15 volt. What is the work done by the battery, my dear friends? What is the work done by the battery, my dear friends? No idea?
1 minute.
1 minute to solve this question. There are two things that you have to remember. One is that we have to remember things. And second, we need to trust ourselves. Work done by the battery is Q into V. To multiply 15 into 20, you don't need to take time. It is 300. Just have to multiply Q by V.
Yes, sir.
Work done by the battery. I hope that the Almighty is going to be there present with you in the examination hall. And I would pray for it sincerely. I would pray for it sincerely. You'll have to, just now I told you to go through everything and no doubts, but you don't remember things. The work done by a battery is Q into V. Do you remember it?
Yes,
These
sir.
are the things
Q
that you
square by
must
C.
remember. Yes?
Q square by C is the work done.
Q square by C. Where do you see C? I don't know. In which universe you are wandering?
Sir, we can write V as Q by C now.
Q by C? What Q by C? Is there any is it mentioned that there is a capacitor there? Which universe you are wondering?
No, sir.
Why are you saying C? Work done by the battery is Q into V. The charge which has flown to the battery multiplied by V. That is how we also define the EMF of the battery. Work done in moving a positive charge from the negative terminal to the positive terminal. You cannot lose those simple things, beta. Do we understand this? Those are the essence of your knowledge. You can't forget these things, beta. It is the cardinal sin to forget the basic definition of work done by the battery. Just can't forget it. Just can't forget it. If you forget it, just last day we have done this and you are forgetting after 1 day. The exam is still 2 months away. The exam is still 2 months away. You will not be able to remember it. Please remember it. Please go through simple things. And I hope that you will be doing it. That is a wrap from my end for this particular chapter. I am done with everything that was possible for me to cover. Everything that can come in the exam, I have covered it. Now it's up to you to do the needful from your end. If you can recollect the things that we had done, remember them, and solve them correctly. You should be good. Take care. God bless you. Bye bye.